Introduction to Databases. Hello, everyone. Welcome to Introduction to Databases. We're going to talk about the fundamentals of how databases work and why they are crucial in modern computing and how they're applied in real-world scenarios. So we're going to look at the definition of a database and the difference between file systems and database systems and the types of databases commonly used and key concepts such as schemas and queries. Overview and objectives. In this lecture, we are going to cover 5 main objectives. First, we're going to understand exactly what a database is and why it's such an important component in almost every application we use daily. Secondly, we are going to compare traditional file systems to modern database systems, seeing how databases address many limitations of simple file storage. Next, we're going to look at two broad categories of databases, which they are relational and non-relational. And, and then we're going to look into core concepts that govern how data is structured and accessed, so such as schemas, tables, and queries. Finally, we're going to look at some real-world use cases to ground these ideas in practical and familiar scenarios. What is a database? So let's begin with the basic definition. A database is an organized collection of data that can be easily accessed, managed, and updated. In here, the key is organized. So databases are designed for storing large amounts of information in a systematic way, and they support efficient retrieval and manipulation of data, uh, thus ensuring accuracy and consistency. For example, let's think of an online bookstore that needs to store information about thousands of books, authors, customer reviews, and order histories. Trying to maintain that information as simple text files or spreadsheets would be cumbersome and prone to errors, especially when multiple people need to access and change the data simultaneously. A database solves these issues by structuring the data and providing robust ways to query and manage it. Why not just use files? Why do we bother with databases instead of simply using files or spreadsheets that we're already familiar with? So traditional file systems can quickly become disorganized and inefficient as data grows. So for example, say you store customer records in a spreadsheet and product information in another file. If you do that, linking that information can get messy. And if you have dealt with spreadsheet with many rows and columns, searching through huge files, it can be really, really slow. And there is really not a good built-in mechanism to handle multiple simultaneous edits without risking data corruption. Databases, on the other hand, are specifically designed to handle these challenges, and they allow multiple users to access the same information concurrently, maintain relationships among different sets of data, and ensure data consistency through strict rules called constraints. Additionally, databases provide security mechanism to protect sensitive information and offer reliable backup and recovery options. Types of databases. So databases come in many flavors, but broadly, we often categorize them into two main types, relational and non-relational, often called NoSQL. Relational databases organize data into tables with rows and columns and rely on a language called SQL, Structured Query Language, to manage and query the data. They're great for structured data with defined relationships. On the other hand, uh, non-relational databases store data in various forms like key value pairs, documents, or graphs, and they excel in scenarios where data is unstructured or rapidly changing. So choosing the right database often depends on the nature of the data and the kind of queries you need to run and the scalability requirements of your application. Relational databases. So relational databases are the traditional, most widely used form of databases. And the examples of these relational databases include MySQL, Postgres, Oracle databases, and Microsoft SQL Server. And in these systems, data is stored in tables, which consist of rows, and you can think of each row as a single record, and columns, uh, which defines specific attributes of those records. And every table typically has a primary key, which is an attribute that uniquely identifies each row and to relate data in one table to data in another. We use foreign keys, which reference the primary key of another table. And this approach maintains clear relationships and data integrity. And relational databases are known for their ACID properties. And ACID stands for atomicity, consistency, isolation, and durability, which ensure reliable transactions and consistent data states, uh, even under heavy usage or system failures. Non-relational databases. Uh, Non-relational databases diverge from the rigid table-based structure of relational databases, and they are built to handle large volumes of data that might be semi-structured, unstructured, or rapidly evolving. So examples include document stores like MongoDB, where data is stored in JSON-like documents, key value stores like Redis, where data is extremely quick to access via simple key lookups, or column-oriented databases such as Cassandra, which offer efficient storage and retrieval of large amounts of data across distributed systems, and graph databases like Neo4j, which focus on relationships between data points. NoSQL databases are often chosen for their scalability and flexibility, and they can handle data growth and changing data models with relative ease. Core database concepts. So before we jump into um, examples, let's first define some of the most important terms you're going to see. First one is a schema. You can think of a schema as the blueprint of your database. So schema describes how data is structured and related. And in relational databases, we store data in tables, and each of which contains rows, and rows represents individual records, and columns represent specific attributes of those records. In order to retrieve or manipulate data, uh, you want to execute queries. And for relational databases, queries are often written in SQL, which is a structured query language, and indexes similar to Book's index. They help databases quickly locate the data you need, boosting performance. And finally, transactions. You can think of them as all or nothing operations ensuring data reliability. So a transaction must either be fully completed or rolled back. And it's set in a way to preserve the integrity of your data. And these concepts form the backbone of how databases store and manage information. Real world use cases. So databases are everywhere in the world. Uh, for example, the e-commerce platform, they use databases to track products, customer orders, shipping details, and payment statuses, so on. And if you look at banks, banking systems, they rely heavily on relational databases to manage millions of transactions that happen every day. And they need to ensure that all the accounts remain accurate. And if you look at social media, these platforms often use combination of relational and non-relational databases to maintain user profiles, friend connections, and messaging systems. And for example, healthcare, uh, you will see that they store patient data, appointment information, and medical histories. And uh, for them, data privacy and security are paramount. And lastly, telecommunication companies, they would use databases to keep track of subscriber data, call records, and billing information. So handling frequent transactions every second. So you can, just looking at these examples, you can see how versatile databases can be, powering pretty much every type of digital service that you interact with. Conclusion. So here are some key takeaways. First, databases are essential for organizing and managing large amounts of data reliably. Second, when deciding between a relational or non-relational database, consider the structure of your data, the performance requirements, and the scalability you need. Third, SQL remains the primary language for working with relational databases, and it is important for you to uh, get comfortable with SQL queries and commands. And finally, core concepts like schemas, keys, indexes, and transactions are the pillars that make databases powerful and dependable. Thank you, everyone, for listening.